Hello ma'am. In this presentation, I'm going to present about swings and AWT. Without any further ado, let's start the presentation. Before that, let me introduce myself. I'm Sai Krishna. I'm currently pursuing my data science bachelor's degree at IARE. This presentation has certain objectives. They are first introduce ourselves to actually what the means of swing and AWT is. Then we will have a deeper discussion about AWT, its components, similarly swings and its components, and the basic differences between swings and AWT. Finally, we will have the conclusion. Let's start with the introduction. Often, AWT is mistaken for swing by Java developers and backend science aspirants, and vice versa. The two terms are distinct and have an extensively broad meaning. Although the field of AWT is analogous to that of swings, yet there is a wide chain of differences between the two. First, let's understand the meaning of two terms and their implications individually. Then, we shall discuss their differences on various bases to get more clarity on AWT and swings. AWT. AWT is the standard abbreviation for Abstract Window Toolkit. It is a platform-dependent API for developing GUI, graphical user interface, or window-based application using Java. It was devised by Sun Microsystems in 1995. It is a heavyweight API and it is usually generated by the system's host operating system. It comes with a significantly higher number of classes and methods, primarily created for designing and managing graphical user interface. So what we have learned from AWT till now that it is a very heavyweight package in Java, and it's basically used to serve the GUI purposes. This is the AWT class hierarchy. There is the components class, which is a subclass of the object class, in which we have several things like button, canvas, checkboxes, choice, label, list, score bar, text component, text area, and text field. Now, what's the difference between text area and text field? In text field, you can only write one editable line of text, whereas in text area, you can write multiple columns. And in containers, we have panels. In panels, we have applets. And in Windows, we have frames and dialog boxes. And in dialog boxes, we have file dialog. This is the basic AWT class hierarchy. Now, let's discuss about the components of AWT. A component is an object with a graphical representation that can be displayed on the screen and is allowed to interact with the user. The component class is the abstract parent of the non-menu related AWT components. So one being the button. Now to create a button object, merely create an instance of the button class by calling any of the constructors. The most commonly used constructor of the button class can take a string argument that gives the button object a text title. So how you can call a button? You can use java.awt.button expression in your compiler. Next is checkboxes. Checkboxes have two states, namely on and off. The state of the button is returned as the object argument when a checkbox event occurs. To find out the state of each checkbox object, we can get getState that returns a true or false value. We can also get the label of the checkbox using getLabel that returns a string object. The commonly used expression to initialize the checkbox is java.awt.checkbox. Next are radio buttons. It is a group of checkboxes where only one of the items in the group can be selected at a time. So that are called radio buttons. Basically, it is used as a slicer when we have multiple categorical variables for us. The basic expression which is used to initialize the radio buttons are java.awt.checkbox group. Choice buttons. Similar to a radio button where we are allowed to make a selection. However, it requires less space and allows us to add items to the menu dynamically using the add item method. Java.awt.choice is the expression that is used to initialize the radio buttons. Next is labels. Used for adding a text description to a point on the applet or the application. The expression that is used to initialize labels are java.awt.label. Now, in the recent update, we can add colors to the labels. The final component of the AWT are text fields. Now, these are areas where the user can enter text. They are read for displaying and receiving text messages. We can make this text field readable only or editable. We can use the set editable false to set the text field read only. The expression that is used to initialize the component is java.awt.textfield. Now let's talk about swings. Swing is another Java toolkit which is a lightweight graphical user interface used for creating various Java applications. The Swing components are platform independent. It allows designers to create buttons and scroll bars. Swing comes with packages for devising desktop applications using Java. Swing components are programmed using the robust Java programming language. It is an important subset of Java foundational classes. Right now, Swing is much more popular when compared to applets because of its lightweight nature and have various features when compared to AWT. This is the basic hierarchy of Swings. That is, we have object class components, so and J components. We have all the Swing components. The first component being the image icon. The image icon component is used for creating an icon-sized image from an image residing at the source URL. JButton. JButton class is used for creating a push button on the UI. The button can contain some display text or images. It generates an event when clicked or double-clicked, which then are collected by the event handling and given an appropriate operation to it. Next is JLabel. Now JLabel class is used for rendering a read-only text label similar to the label in the AWT or images on the UI. It does not generate any events. It's just for presenting an information to the user. We have text fields, JText field. Now JText field renders an editable single-line text box. A user is allowed to input non-formatted text in the box. The components of the string next is JPassword field. JPassword field is a subclass of JTextField class. It renders a text box that masks the user input text with bullet points. This is used for inserting passwords into the applications, and we are very much aware of this component in our day-to-day life, without which our passwords do not have the privacy when used publicly. Next are checkboxes. Checkbox renders a checkbox with a label. The checkbox has two states, one being the on and the off. When selected, the state is on, and when not, it is off. Radio buttons. As discussed earlier in the AWT, JRadio button is used to render a group of radio buttons or checkboxes in the UI. A designer can only select one choice from the group. JList. JList components renders a scrollable list of elements. A designer can select a value or multiple values from the list. This select behavior is defined in the code by the developer by triggering a expression. Now let's talk about the main differences between the Spring and the AWT. Being a Java aspirant, you must distinctively understand the difference between the two widely used developmental terms, AWT and Swing. After reading the above-mentioned introduction, you must now go through the head-to-head comparison between the two through the difference table given below. In the context of API package, the AWT component classes are provided by the java.awt package. The Swing component classes are provided by the javax.swing package. In the context of operating system, the component used in AWT are dependent on the operating system, whereas in the Swings, they are independent of the operating system and completely dependent on Java. Weightness. Deliverability is heavyweight since it uses the resources of the operating system, whereas the Spring is mostly lightweight since it does not need any operating system object for processing. The Spring components are built on the top of AWT. Appearance. The appearance of AWT components is mainly not configurable. It generally depends on the operating system looks and feels. The Spring components are configurable and mainly support a pluggable look and feel. Number of components. The Java AWT provides a small number of components comparison to Swing. Java Swing provides a greater number of components than AWT such as list, scroll panes, table, color, choosers, etc. Peers. Java AWT has 21 peers. There is one peer for each control and one peer for the dialog. Peers are provided by the operating system in the form of widgets themselves. Java Swings has only one peer in the form of OS window object which provide the drawing surface used to draw the Swing widgets, label, button, entry field, etc. Developed directly by Java Swing package. Functionality and implementation. Java AWT many features that are completely developed by the developer. It serves as a thin layer of development on top of the OS. Swing components provide the higher level inbuilt functions for the developer that facilitate the coder to write less code. Memory. Java AWT needs a higher amount of memory for the execution. Java Swing, on the other hand, utilizes less memory and space. Speed. Java AWT is slower than Swing in terms of performance. So, what is the conclusion then? AWT and Swing are both in use, but their implementation is decided on the basis of the platform dependency criteria, MVC pattern execution time, and other functionalities. However, both of them are unique and separate entities. Each comes with its own components and cons and specific business use cases. But it is okay to say that Swing are a modern version for GUI development when compared to AWT and Applets. With this slide, I want to complete this presentation. Thank you for listening. Have a great day.